The topic that we want to cover in today's video is the distributive property. And we want to see its use in various types of examples. Distributive property is just really another name for, or another description for using multiplication, but using it multiple times. So let's say we have negative 3a times a to the fourth plus 2a cubed minus 6a squared plus 8. Remember, if there is no operational symbol between a number and a variable, or an expression or a term and parentheses, it's telling us to multiply. And specifically what this is telling us to do is to multiply 4 different times. And so what we are doing is distributing this negative 3a to each of those 4 terms. And so what do we get? Well, recall under your laws of exponents, when you multiply and you have the same base, you add the exponents. So you get negative 3a to the fifth, negative 6a to the fourth, plus 18a cubed minus 24a. You will notice that none of the 4 terms are like terms, because even though they all have an a, each a has a different exponent. We are done simplifying this expression. Now let's contrast that with the following. 2 times 3x minus 2 minus 3 times 6x plus 4. Here you'll notice that we are distributing 2 different times. First, I'm going to distribute the 2 to get 6x minus 4. And then next, I'm going to distribute a minus 3. Common mistake is for students to miss the sign to the left. And the reason I'm calling it a minus 3 or negative 3 is because subtracting a number is the same as adding its opposite. So minus 3 is the same as adding a negative 3. So this becomes negative 18x minus 12. Now here, we do have like terms. So I can further simplify this to negative 12x minus 16. And the point of all of this is that what we've done is we've taken a more elaborate expression and culled it down into just 2 separate terms. Now, the more used situation, or the more commonly used situation for distribution, is not when we're just distributing 1 term, but in essence, we're distributing 2. So let's say I have the following 2 binomials, x plus 7 times x minus 6. Well, there's really 3 different ways that this multiplication can be visualized. The first way is to visualize it as I'm distributing the 2 terms, and now there are 2 terms in each one because they're separated by a plus or a minus. So I'm distributing each of these 2 terms in the first binomial to the second binomial. So I can rewrite this as x times x minus 6 plus 7 times x minus 6. This representation should be familiar to you from our grouping concept of factoring. Okay? If I were to pull this back together to here, the right to the left, you will see that the grouping leads me to these 2 binomials. But that's not what I'm trying to do right now. I'm trying to expand it. So now, what do I get? I distribute to get x squared minus 6x plus 7x minus 6. And you should be able to notice the 2 like terms. That simplifies this to x squared plus x. And I'm sorry, not minus 6, but that's a minus 42. So please don't send in your letters for my mistake. And that's what this binomial simplifies to. Now, there are 2 other representations of this multiplication. And you are likely to come up with one of the 3 that you are going to have a preference for. It's whatever you are comfortable with. I'm multiplying a binomial times a binomial. So a visual, more geometric representation of this is this schematic setting up quadrants. And I have 4 quadrants because I'm going to multiply 4 times, and I have a binomial and a binomial. Doesn't matter which one goes where, not at all. Now, the result in each box is going to be the multiplication of the outside parts. X squared, 7x, negative 6x, and negative 42. Didn't make that mistake twice. All right. Then I combine what are like terms to get x squared plus x minus 42. So that's another strategy you can use to do that multiplication. There is a third strategy, and this has been taught for many years by teachers, and it has some usage, but it has limited usage. And what this strategy is if you are multiplying a binomial times a binomial, which means you're going to multiply 4 times, teachers would teach this acronym of FOIL. And each letter is meant to stop the student from multiplying the same 2 parts or same 2 terms twice. So F stands for first, O is outer, I is inner, and L is last. So what are my first terms? X times X. What are my outer terms? X and the negative 6. What are my inner terms? 7 and X. And my last terms, 7 and negative 6. Obviously, we keep getting down to the same answer, which we should be, but you can use whichever of the 3 methods you are comfortable with. Now, why is FOIL of limited use? Well, let's say we were going to do the following. 2x minus 3 times 4x squared plus x minus 6. Now I no longer have a binomial times a binomial, but a binomial times a trinomial. And since I have 2 terms and 3 terms, I'm going to be multiplying 6 times. Well, method 1, distribute. 8x cubed plus 2x squared minus 12x minus 12x squared minus 3x and plus 18. We're not done. I have to combine like terms. Nothing is a like term with the 8, x cubed. I have like terms here to have a negative 10x squared. I have like terms here to have a negative 15x, and then my positive 18. However, you can use the box representation I showed you previously. The box will look a little different because I have a trinomial and a binomial. So now you'll see I have 6 squares. I'm going to put the trinomial on the top. Sorry, putting a plus x, although I don't need to. Minus 6 and 2x and a minus 3. Again, could I flip-flop these to put the binomial and the trinomial? Yes. Now I do the multiplication. 8x cubed, 2x squared, negative 12x, negative 12x squared, negative 3x, and a positive 18. Again, you put together your like terms, and you get the exact same result as above. Your choice as to which of those 2 you want to use. Now, a couple of additional points with regard to multiplication and binomials. Common mistake students will make is something of the following. Does x plus 5 in parentheses squared equal x squared plus 25? Well, hopefully you will remember from an earlier video on the laws of exponents that if you distribute this exponent when you have multiplication inside, you're violating the laws of operations because you're telling us to multiply, that's what distributing an exponent is, before adding. Well, if you think about what squaring something means to multiply whatever it is by itself. We'll multiply these two binomials. I get x squared plus 5x plus 5x plus 25. Or x squared plus 10x plus 25. As you will notice, our final correct answer has a middle term that's missing from this incorrect answer, so that I should put my line through there. A final example, a question you may commonly see, is the length of a rectangle is represented by the expression 2x minus 3, and its width is represented by the expression x plus 4. Write an expression for the area of that rectangle in simplest form. Well, recall, area of a rectangle is length times width. So all they're asking you to do is to multiply these two binomials. 2x squared plus 8x minus 3x and minus 12. Combine your like terms, 2x squared plus 5x minus 12, and you now have a simplified representation for the area of this rectangle. So, what are the key things in terms of multiplying or distributing? Is make sure you're following your laws of exponents. Make sure that after you distribute, you combine your like terms so that your answer is in simplest form.